In the previous videos, we took a look at it, basically going through and finding the equations of lines through points, and finding the equations of lines given certain conditions, and then also finding the slopes. So in this section, we're going to take a little bit deeper dive, and we're really going to focus on parallel and perpendicular lines. And realistically, the concepts aren't too difficult. The only thing that might be difficult is some of the algebraic manipulatives as we get through. And so what we're going to do in this section is we're basically going to find the slopes of lines that are parallel to given lines and perpendicular to given lines. It'll be pretty easy. And then we're going to find equations of lines both parallel and perpendicular to given lines through a given point. Right. So let's first of all define what it means for two lines to be parallel and two lines to be perpendicular. Two lines are parallel if they exhibit the following properties. First of all, they'll never intersect, which means that they have to have the same slopes. Okay, and that's probably the most important thing that we can get out of this. Okay, so if we have two equations of lines that are parallel, their m's are going to be the same. Okay, so we could say something like m1 is going to be equal to m2. They usually almost, in fact, they almost always, and for our purposes, they will have different y-intercepts. And because they're parallel, they're like train tracks. They'll never intersect. And so they have like that sort of sideways slash to them. And we can see down here in this diagram that these two lines, they have the same slope because the coefficient of x is our slope, and the intercepts are 4 and -3 respectively. Perpendicular lines form 90-degree angles when they intersect. The most important thing to remember about these is that they have opposite and reciprocal slopes, and I'll show you how to compute those in a few moments. Whenever you see this upside down T, that means that we're looking at perpendicular lines. Okay, so perpendicular diagram might be down here, all right, where we have this sort of thing, where we have one line that intersects another line, but at their point of intersection, it's a right angle. And so let's just go ahead and if I give you a slope, let's make sure that we understand how to find the perpendicular and the parallel slopes. Now recall that parallel slopes have the same slopes and perpendicular slopes are opposite and reciprocal slopes. All right, so it's really easy if I give you the slope -2/7 to find the parallel slope because that's also -2/7. It's also easy to find the parallel slope to 5 because that's also going to be 5. And if I ask you the parallel slope of 0, that'll also be 0. Now, opposite reciprocal for perpendicular slopes. So we know that the opposite of a negative is a positive. So whatever our slope is, it's going to be a positive slope. And then all we're going to do is just flip over the fraction. Okay, so it's just going to be +7/2. If you want to get rid of the positive sign, that's fine. I'm just going to write it in there just so that way we can make sure that we know explicitly what's being said here. Okay, so that's it. To be able to find the perpendicular slope to 5, think of 5 as 5/1. We know the opposite of positive is negative. And then if we flip over 5, or 5/1, that's going to be -1/5. And you're probably thinking, okay, well, that works for 5. It should work for 0. So we can write 0 is 0/1. So the perpendicular slope would be 1/0, but that's just undefined. Right? So we know that the perpendicular slope is going to be undefined. Let me erase this so we can fit in there. All right. So perpendicular to 0 is going to be undefined. Right. And think about this. Remember we said that if you have a slope of 0, that's going to be a horizontal line. And if it's undefined, it's vertical. And so if I draw a vertical line intersecting with a horizontal line, it certainly forms a right angle at that point of intersection. So what are we going to do with this knowledge? Well, what we're going to do is we're going to be able to find equations of lines that are parallel and perpendicular to other lines. So let's take a look at an example of this. So let's try to find the equation of a line in both point slope form and general form. Okay, so let's before we go any further with this, let's just remind ourselves what point slope and general form is. So point slope is going to be of the form y minus y1 is equal to m x minus x1. Okay, we did that several times, probably like about 7 or 8 times in the previous videos. Okay, but general form we didn't look at. And just as a reminder, for general form, that's going to be ax plus by plus c is equal to 0. Where a, b, and c, we're going to make those into integer values. All right, so let's hold on to those. And then we can go ahead and now try to do one of these problems. We want to try to find the equation line that passes through the point 1, 2, and it's going to be parallel to y equals 4x plus 1. So anytime you want to build the equation of a line, you have to have two things. You have to have a slope, and you have to have a point on that line. Now, the good news is we have the point on the line as 1, 2. The bad news is we don't have a slope immediately. But let's take a look at the equation. Y equals 4x plus 1. And remember in the previous videos that this is in the slope-intercept form. And so the slope of this line is going to be 4, and the y-intercept of this line is going to be 1. And we really don't need the y-intercept, we just need the slope. Now the slope is 4, but we need the parallel slope. But remember, up here, didn't we say that two lines that are parallel have the same slope? So the parallel slope is also going to be 4. So that's what we do. We take a look at the given line, and we try to find the slope of the given line, and then try to find a parallel slope to that. So now what we can do is we can employ our two formulas. Okay, so we're going to employ both the point slope and the general formula. And so that's going to mean that we're going to have y minus y1, which is 2. It's going to be equal to 4, which is our slope, that's parallel, quantity x minus x1, which is going to be 1. Okay, and again, we got the 1 right from here. So that's half of our answer right there. And this is going to be our point slope formula. Now, let's put it in the general form. To put it in the general form, I'm going to distribute the 4. So that's going to be y minus 2 equals 4x minus 4. And then I can go ahead and I can put this into the slope-intercept form by adding 2 to both sides. And that never hurts because to me, this is the most useful of all the forms. So y equals 4x minus 2. Okay, so that's not our answer. That's the slope-intercept form. All right, but they're asking us for this general form, ax plus by equals c. And so for us to get there, what we're going to do is we're just going to move the 4x and the negative 2 to the other side by subtracting 4x and adding 2. Okay, so we're going to subtract 4x and we're going to add 2. And so we would get y minus 4x plus 2. And then on this side, that's going to be equal to 0. Okay, or if we wanted to write it in the order of ax plus by equals c, we would rearrange these two terms, and we would rewrite that as negative 4x plus y plus 2 equals 0. All right, and that's probably going to be the form that we need to put it into the general form. Okay, so in this video, we saw not only how to go through and find the equations of a parallel line, but we also took a look at how to find parallel slopes and perpendicular slopes, and then also how to put it into the 3 forms that we're probably going to use most often: point slope, slope intercept, and general form. So in our next video, we're going to take a look at a few more examples of parallel lines, and then we're going to take a look at how do we deal with perpendicular lines.